Hey everybody! In this video, we are dealing with factoring polynomials and various techniques. Alright, this picture is a problem that a student worked on the board, and we just want to do a little bit of error analysis. You guys seen me do this before on quizzes and the stuff that you did the first day you met me. So let's look at his work and analyze it. So this is the problem. Negative 27 u cubed plus 125. As the person wrote it, this is their final answer right here. So, before we begin, let's look at what the student did do well. Well, the student know that in the back parentheses, well, let's start with the obvious. The student knew that 125 could be rewritten as 5 times 5 times 5 because you're dealing with cubes. So that's 3 5s and the dot stands for multiplication. So you know that in the back, you're going to have 2 5s. And then he know that the 3 u's could be written as u times u times u. And he know that that's supposed to be 2 u's in the 2 u's right there. And he also knew he had to combine stuff together in the middle, and he knew that the signs were supposed to change. All right? So that's what he or she did well. So let's talk about things that kind of threw us off a little bit. So we knew for a fact this negative 27u could be broken down in terms of 3 u's. I mean, 3 3's. 3 negative 3's actually. Negative 3, negative 3, negative 3. So we know that it was supposed to be broken down like that. So his final answer, or her final answer, should be negative 3u plus 5. And that's in the front. I'm not done with all the pieces because I got to worry about the back. So in the back, we got to fix the middle piece. Because apparently he or she forgot that you have all this going on. You have 3 negative 3's. You have 3 u's and 3 5's. So you know in the front, we took out 1 negative 3 and 1 u. And we know we took out 1 5. All right, so let's work on what's in the back. So in the back, we know that this is supposed to be 2 of the a terms. So there's supposed to be 2 negative 3's left. So we know that negative 3 times negative 3 is what? 2 negatives make a positive, so it's positive 9u squared. Okay? And we know in the far back, we're going to get positive 25. Maybe I need to rewrite that for some of you guys who struggle with that handwriting of mine. Okay? So the middle term, you're supposed to combine both the negative 3 times the 5, well, negative 3u, correction, let me rewrite that. Negative 3u times 5. So negative 3 times negative 5 is what? Negative 3 times positive 5, I'm sorry. Negative 15u. All right, now we got one thing left to do. So we know that our final answer should have something like this. A plus B, A squared minus AB, A times B that is, plus B squared. Okay, so the middle term, we got the negative 15u. We know for a fact that when we multiply the negative 3u times 5, we get negative 15u, but we already start out with the negative anyway, right there. So that negative in the final answer is going to become positive 15. So that should be the final answer of that. So again, your final answer should be negative 3u plus 5, and then open parentheses, 9u squared plus 15u plus 25. That's what your final answer should be. All right. If you got any more questions, we could talk about it. We could do more practice on that. I would try to do some more practice Kahoots for the sum and difference of cubes. All right. All right, guys. Now we got some drama to contend with. We got 125x9 minus y6. Now, before you freak out because you see those exponents, because you know how you get, oh my God, it's something completely different. Run away. You don't need all that. Let's chill out. So remember, because this is still dealing with the difference of cubes, and we know this because 125 is a cube root of 5. So we know that. And because of that, we know we're supposed to rewrite this to make this work. So we know our final answer should look something like 5x minus, because it's the difference of cubes, y. That's how it starts off with. All right? So if I took one of those, I took a 5, I took an x, and I took a negative y. So in your parentheses in the back, you know how many you should have in the back. You know you're going to have two 5x squareds, well, two 5x's, and we know we're going to have two y's as well, and we know that it's going to be positive because that's what the formula tells us. All right? And we know that in the middle, we just combine one of each. Combine 5x and combine the y. So again, because you took us 3 of those, so what's going to be left to make this easier on us? Just do this. X, because we took 3 of each. So we took, the 125 stays the same, so we're just dealing with the x's in this case because they're so high powered, 9 and 6. And remember, you took 3 all right. You took 2 in the back, and then you took 1 right here. So we know we took 3 y's so far. So we're going to be left with, just 3 y's left, because we took away 6 of them already. So this is going to be cube right here, because that's what you're pulling out. And the x's, because I took 3 of those x's, I'm going to have 6 x's left. And of course, here you could use a minus sign. Because again, you took 2 x's here in the back, and then you took one in the center, which makes 3 x's. And you're going to be left with just 6 x's. As you put what you took, what you have left over, you put it right here. I know that seems challenging, but look, we're going to do more practice of this because for test purposes, you're going to know how to work like that. So again, because this is the difference of cubes, you're going to always have the 3 that you got here and whatever you have left over in the forefront. Like I was saying, you're always going to deal with 3. So say, for example, if I was to say A4 plus B8, just saying, because again, I'm dealing with cubes and I want stuff to be in the cube format, and I'm going to tell you what format I want this in. So because I want it in cube form, I know in the front, well, let's do this. So let's subtract. So 4 A starting off with minus the 3 A's that I'm going to take away from that 4 is what? In the very form, I have 1A. So the B's, there's 8 of them, and I'm taking away 3 of them. What am I left with? 5 B's. So in the very front of my answer, very front, I should have A plus B to the power of 5 because I'm taking stuff away. It then goes A plus B because you're following the formula. And then AX squared minus AB plus B squared. And that's what you're doing. So don't let these high exponents fool you. If I say put it in cubic form, that's what you're going to do. All right? You're just pulling away. All right? All right. Now suppose now I'm dealing with squares and cubes. Well, in this case, I'm dealing with squares because we already did cubes. And I got exponent of 4. Guess what? X plus 1. X minus 1, how we will have our final answer, right? Because that's the difference of squares. So remember this part. But what's left? Because how many x's did I take away from that 4? 2. So what you have left over of this is going to be x squared plus 1. When you're dealing with squares, it's easier to check your work that way. So let's just check our work. So we get x squared negative x plus x minus 1. And when we do that, that cancels. So that's x squared minus 1. And then we're going to do x squared plus 1. Don't forget, this is how I want you to always check your work. So x squared minus x squared, that's x fourth power. X squared times negative 1 is negative x squared. x 1 times x squared is positive x squared. 1 times -1, -1. And when I cancel that, I'm left with x to the power of 4 minus 1. And that's how you check your work. So remember, when you're dealing with this guy, power of 4, or some type of even power, you're always going to write it like this. So if that was 6, you would just say no. Well, yeah, we could do 6. So if I was to say, instead of it being 4, x6 minus 1, of course, because I know I'm dealing with different squares, x plus 1, x minus 1. How many x's did I take away? 2. So what's going to be left? 4 of them plus 1. And when you factor that, you're still going to have the same answer. Well, for it, you're going to have the same answer as this guy right here. So that's just ways of dealing with different squares with crazy exponents that are bigger than square, which is 2. And that's that formula that I was talking to you guys about, the difference of squares, which is going to be important for you to know. I posted some stuff in Google Classroom, some material for you to look at and to prepare for. And this is a way where you really don't have to keep your notes after you do your quiz and do your revisions and stuff like that. You could throw your notes in the trash and just look at Google Classroom for those notes to review for your test and your quiz, because this is what's going to help you do well on my test. All right. All right, let's pick up where we left off from last class. And this is before y'all took my quiz. So, we know these are polynomials. So let me ask you about the first one. You got 18x6 and 12x cubed. So let me ask you, what type of polynomial is this? Is this a trinomial, monomial, or binomial? Mono. Because it's just one term. Just one term. Mono means one. So what is the greatest common factor of in terms of coefficients? And again, coefficient is number is front. 18 and 12. So let's do it. 8 and 12. In case you don't know the greatest common factor by now. So let's do it. We know 1 times 18 gives me 18. We know 2 times 9 gives me 18. And we know that 3 times 6 gives me 18. Let's do 12. 1 and 12 gives me 12. 2 and 6 gives me 12. 3 and 4 gives me 12. All right? So we know the biggest number that 18 and 12 have in common is 6. We have a 6 to come here and a 6 there. And that's the biggest number both 18 and 12 have in common. So 6. So let's look at the variables. x6, x3. Remember, there's two ways to doing this. We could draw all the x's, or you could look for the smallest variable, which is x3. It's the smallest between 6 and 3, but it's the biggest thing that 6 and 3 have in common. So let's do this again. Let's draw our 6 x's. Both 6 and 3 have at least 3 x's. So the 6 power n cube have at least 3 x's, known as x cubed. All right, so that's that. So let's look at the second problem. The second problem, what type of polynomial is that? Binomial, 2 terms. Because you know this, because it's separated by at least one operator, and that operator is subtraction. All right. So let's go for coefficients first. 9 and 3. The greatest common factor of 9 and 3 is 3. Okay. So let's go look at the x's. We got x here and then x here. I got x to the 7th power right here, x to the 2nd power. Which one I'm going to go for? X to the power of 2, because the 7th power and square have at least two exponent of 2 that you could pull out. All right, so let's do the y's. I got y to the 5th and y to the 6th power. So what can I pull out from both 5 and 6? I could pull out a 5, because before I get to 6, I got to get to 5. Bam. All right, let's do this last guy. I'm going to put this on top. What type of polynomial is this? A trinomial. All right. So what is the greatest common factor of 36, 63, and 27? But we got to think of coefficient and variables. So good eye. So in terms of the coefficient, it's going to be 9. And in terms of the variable, it's going to be just x. What's going to be left inside the parentheses? Oh, whoa, slow my roll. I'm going a little too fast. We're going to get back to the trinomial later on. I got to get back to the binomial because that's not finished. So because it's a binomial, you got to deal with what's left in the inside. So we pulled out a 3x squared 7 y to the 5th power. So what's going to be left? I'm going to have left 3x to the 5th power minus, what I'm going to have left over here. I took a 3x squared y to the 5th power, so that's just going to be y, just y to the power of 1, or just y by itself. So for those who kind of used to putting 1, you could do that, or you could just leave it alone, just be y. So it's up to you. I'm personally just like to erase the 1 because I know for a fact that's y to the 1st power. All right. Let's check our work right quick. Just make sure we're together. This is all one term, so 3x squared y to the 5th power times 3x to the 5th. That is going to be 9x to the 7th power y 5th. All right, so let's go 3x squared y 5th times negative y. That's going to be negative 3x squared y to the 6th power. And this is what I start off with. So that's how you know I'm finished. Because it matches all of this right here. All right, so let's get back to the trinomial. All right. sometimes you gotta be careful. That binomial, it get at you because this is the second time I pulled out stuff the greatest common factor, but I didn't do anything with the parentheses. Y'all don't make the same mistake I made. So let's get back to the trinomial. So what am I left with? And inside my parentheses. So I know that I need 4x squared because 9x times 4x squared is going to be 36x cubed. Okay, what about this 63? I know that is going to be plus 7x. All right, minus 3. And that's how you factor by using the greatest common factor. And these are things that we did. All right, let us proceed. All right, what is the precise definition of mathematics? It is the technique to explain, understand, and manage reality specifically by ciphering, counting, measuring, classifying, ordering, inferring, and modeling patterns arising in the environment. You guys must know this definition because you saw it on my quiz, and you're going to see it again, pretty sure, on my test. And you may have to use that again in your project as it was in the first project. You guys got 2 more projects to contend with. Now, a fine example of this definition that I'm going to share with you is modeling patterns arising in the environment. All right, example of me modeling patterns arising in the environment. Are you ready to take a test? Are you ready to take my test? So, me, who's the college student of LSU, I ask myself this all the time, as much as you guys ask yourself this or say, I'm not ready for Mr. Howard's test. His test too much. He'd be wrong on his test. So, guys, the environment in this case is going to be the test. So, I got to determine, am I ready for my test? Ready to take a test? What you see here, this is the model. This is the model that I use to determine, am I ready to take a test? And you guys are more than welcome to, figure this out for yourself too. And I'm going to tell you what all these variables represent. All right? All right. So, guys, when you're thinking about taking a test, you think about factors that variables, meaning the situations that you have to contend with. Like, for example, do you have all your notes? Were you here every class period? Those are the variables you create to determine how prepared are you. So this example that you see is variables that I use to determine, am I ready to take a test or not? For example, the I is the variable. The I represents the points of events that I go to. Like, for example, am I having to go to a birthday party? Or do I have to do this and do this and do that for the person who's staying in my house who I'm being responsible for until the end of the semester? For you high schoolers, the events that you thinking about is like, oh, I play sports, I play band, or whatever events that you got going on that's going to either help you study or take away from your time. Mainly take away from your time. All right? So S being the hours of sleep I had last night. And that means just the night before the test. Like sometimes when I'm grading papers and preparing my lessons for you guys, I don't get done with grading and updating grades until sometimes 1 o'clock in the morning. And so when I got a test to take, if I don't get enough rest, I'm gonna struggle through the test. All right? And don't forget each variable that you see, like the I and the S, is going to be a specific number that you set. All right, C, how much coffee I have, to stay awake. Coffee, I like to go to Starbucks, get my coffee on. You guys, it may be make sure that you ate breakfast or make sure you eat a good meal or, have enough gum or whatever is you use to stay awake. All right, so let's talk about P. P is the hours preparation needed to excel. So you guys don't really have to think like that. I do because usually in order for me to do good on any test that I take, I have to have at least a good 10 hours, not in one sitting, but in total of 10 hours to study and prepare myself for the test. Okay? This other variable, P of A, how many hours did I actually study for? Like if I study like an hour, just 1 hour out of the 10, 1 out of 10 is 20%. So I got a low chance of passing my test. All right. D talks about the difficulty of the subject matter. If it's for you guys algebra 2 and the stuff that I go seem a bit difficult because you haven't seen it before and it demands stuff that you forgot because some stuff that you needed was so middle school, like the law of exponent. I mean, if you guys forgot about the law of exponents, but I remind you often as possible to make sure you don't forget about that so you could do what we need to do with polynomials. N represented the nervousness. How much nervous I am between the scale of 1 to 10. 10 being that I just can't function, or tightrope across Grand Canyon. And of course, what it should equal to, that number that I'm looking for. So if P, prepared, is greater than 1, I'll be just fine for my test. So if all your calculations is over just 1, the integer 1, guess what? You good for your test. So I may let you guys try this out for yourself to see how you prepare for like another quiz or something like that, dealing with polynomials, factoring in particular. All right. Now, factor with various methods. All right, guys, we got a series of factoring techniques to deal with of polynomials. So here, this method that I'm teaching you is factoring by grouping. So to do this, you got a polynomial, right? Split them up by binomials. Put parentheses sets here and here. All right. So in the binomial to the left, what is the thing that they have in common? The biggest thing that they have in common is x squared, and what's going to be inside of that is going to be x plus 4. Use distributive property to check your work. All right. So let me go to my second binomial. I got a positive 3x plus 12. The greatest common factor of all of that, what they have in common is a 3. And that's a nice. What's going to be left from the inside? X plus 4. So let's write it. The things that you pulled out, you're going to have it in one term right here, x squared plus 3. And then the things that are left inside the parentheses, x plus 4. And that is how you factor by grouping. All right, let's do some more practice. All right, let's do this. The first problem, split up that polynomial into groups of binomials. All right, so the first binomial have what in common? 5m. What's going to be left? N plus 5. So let's look at the second binomial that we pulled out. The greatest common factor that they have is a 3n squared. And what's going to be left? N plus 5. All right, the things that you pulled out, 5m plus 3n squared. And the things that you have left, n plus 5. Remember, your answer, you must always have things in parentheses to be the same. Always, always, always. If not, you may have to do some rearranging. And we're going to come across that in this next problem. All right. So let's break this up. And I'm doing the second problem. So put the polynomial into two groups of binomial, because we are factoring by grouping. So in the first binomial, 42ab minus 25b, what do they have in common? A b. What's going to be left? 42a minus 25. Okay, so let's look at the second binomial. What do they have in common? Remember the special rule about things in front. So because you got a negative 35, well, a negative number in front, that means the thing that they're going to have in common is a negative number. Well, in this, let me take that back. Don't worry about the negative sign at the moment. That's not important to us right now. Don't worry about that. Do not worry about that negative number at the moment. So what do they have in common? Is what I want you to worry about. They both have a 5 in common. What's going to be left inside? Negative 7a plus 6b squared. Do we have anything? Let's look at the parentheses. Are they the same? these are not the same. And also I wrote that 2 outside my parentheses, which you can't do that. So guess what? We got to rearrange some things and fix some things to make some things happen. So again, this, we can't have that. The stuff inside the parentheses must be the same. So let's fix it. So in this case, you want to rearrange your stuff. So let's rearrange some things. So you're going to rearrange by things that you know they're going to have something in common. Rearrange so you could work things out when you put them in binomials. So 42AB, I know 42 definitely don't have nothing with 25, so I need to see which term gonna have something in common with 42. You're right, negative 35, because they're gonna have the same. They're gonna have a coefficient and a variable in common. They're gonna have a coefficient and a variable in common, not just one or the other, both coefficient and variable. So let's do it. So 42 and 35 have the following in common. They have a 7. Let me write that in red. They have a 7A in common. All right? So when I rewrite all that, it's going to be easy to work with. So let's look at the 25, negative 25b, and the positive 30. I got to change my color. Let me do it in black. So I know for the fact that they are going to have a 5b in common. So when I rearrange this, it's easier for me to do. So let's do it. In red, I'm going to rearrange it. So 42AB. And because I got minus 35, I'm going to have to bring that to minus 35A. All right. Now, let's do the negative 25 because it's negative 25. I got to bring that. Be careful about your signs because that's what you have in the problem originally. That's what you need to bring around. I got negative 25b. And I got a negative 30. I mean, a positive 30b squared. Now, I got them in groups where I now could factor out a few things. All right. Let's do this. So we know for a fact that the first binomial is going to have a 7a common. What I'm going to be left with? 6b minus 5. All right. So in the other binomial, I know I got a 5b in common. And what am I left with in this? I'm left with a negative 5 plus 6b. Oh, wait, Mr. Howard. Wait. They're not the same. They're different too. Nuh-uh. I would disagree with you. Remember what I told you? Well, that you have to rearrange sometimes? Well, guess what? Let's look at it closely. So we got 6b minus 5. My 6b, is it positive or negative? My 6b is positive. And guess what? Do I have a positive 6b here? I do. All right. I have a negative 5 right here. Also here. So they are the same. I just had to rewrite them. As long as the number inside the parentheses at this step are the same, the number inside the parentheses at this step are the same, you could rewrite this. So let's do it. The things I pulled out, 7a plus 5b is what I pulled out. Okay? What I'm left with, my 6b's are both positive here, and then I got a minus 5 because they're both negatives there. And that is how you do that problem. And again, the 3 dots means that you're confident in your answers, you're good, and you're golden. Whew, I know this is a lot, but we're going to get through it. All right, y'all. Now, we got to factor trinomials. We did all that with the polynomials. Let's do the trinomials. And we did this before. So when you're factoring a trinomial, when the a is greater than 1, remember this notation? Because we did this when we was dealing with cubes and squares. So remember this format, ax squared plus bx plus c. Remember this format? That's the standard form. And we know that a, b, and c are integers. We don't just say numbers no more, we just call them integers. So what this is saying, the coefficient is 1. So let's look at this. Don't get confused with the variable a. Let's look for the coefficient that is in front of the a. We don't have one. But remember, when you see a variable by itself, it's always understood to have a coefficient of 1. So guess what? We could factor this. Remember, what two numbers multiplied together gives you 18? And those same two numbers, when you add them together, gives you 11. 2 times 9 is 18. 2 plus 9 equals 11. So x plus 2, x plus 9. And again, you guys seen it as Algebra 1, and you saw this in parts of geometry. So if you need more practice with factored trinomials when the case is a equals 1, then there's more practice. That's in Google Classroom. So let's move on. So that's case 1. We got a different case. Case 2, when a is greater than 1. So out of this, and this is still that trinomial that you're dealing with. Tri means how many? 3. ax squared plus bx plus c. And a, b, and c are what? Coefficients. So what is a in this case? A is 3. B is -2. And C is -5. All right. You guys ready? Because this is my favorite method. So all the factoring methods we're going to do today, this is my favorite one. So in this case, multiply A times C. So this is 3 times -5, which is 3 times -5 is -15. Okay? Then you're going to rewrite it. P squared minus 2p minus 15. All right. What two numbers, when you multiply together, gives you that negative 15, and those same two numbers, when you add them, gives you negative 2. And you should know this because you did it already. You did it in the beginning step. So 3 times negative 5 is 15. 3 plus negative 5 is negative 2. So x minus 5, x plus 3. I'm not finished with this one yet, because guess what I got to do now? The leading coefficient from the original was 3. I got to divide both of these by 3. So when I divide 5 into 3, do I have an integer? No. I get some rational or irrational answer, and that means just something with decimals. Because I have a quotient with a decimal, you take the 3 and you swing it to the front. 3x minus 5. All right. Here, x plus 3. Remember, you're going to divide 3 by 3. So do I get an integer? Yep, I get integer of 1. And you are finished. And that is called the swing method. All right, let's talk about another case. Factoring when you have two squares. So what I mean by squares, what am I talking about? Of course, I'm talking about things to the power of 2. 4 is a square. 9 is a square. 16 is a square. 25 and 36 are squares. And we could keep going, but I'd rather not spend time on this. So when you have two squares like 25 and 36, remember the standard form, ax squared plus bx plus c? So two of them are perfect squares. A is a perfect square of what? 5. C, 36 is a perfect square of 6. All right? So we know that since we got perfect squares to contend with, we should have our factoring to look like this. So 25, if a perfect is a perfect square of 5, and because we got two x's, 5x. All right? But remember, we have 36 too. So 36 is a perfect square of 6. So let me ask you this question. So we got a proposition to deal with. So if I was to, I don't know, figure out how am I going to decide if that's going to be a plus or a minus? How will I determine this? Because the stuff that we did in case 2 is not going to work in case 3 because you're dealing with two squares. And because of that, it's not going to work. So here, is it going to be a difference of squares? Because that's what I've been preaching about a lot. it won't be the difference of squares because different squares, we may know that this middle term will cancel out when we do that. So I give you a hint. So we know we got 5 and 6, right? So my question to you, what two numbers, well, we know what square times itself gonna give me 36. We know 6 times 6 is gonna be there, but that's another one that we should try out too. What about negative 6 times negative 6? That's negative 36, right? It is. Two negatives make a positive. So why don't you try this? 5x minus 6. And let's factor it and see, do we get this guy? So let's do it. So we know 5x times 5x is 25x squared. 5 times negative 6 is negative 30x. Negative 6 times positive 5 is negative 30x. And negative 6 times negative 6 is positive 36. So when we factor this out, we get 25, well, we do this 25x squared minus 60x plus 36. So guess what? That's what we got. That's what we started off with. So the rule of thumb of this particular problem, if you got perfect squares in the front and perfect squares in the back, if you have something like this, that means you're going to have a minus b, a minus b, and all these are just other letters, right? So that means you're going to have two negatives, because when you multiply two negatives like we did, we end up with 25x minus 30x minus 30x plus 36. And when we simplify that, we got 25x squared minus 60x plus 36. So when it looks like this, your factor form is going to be two negatives. But if it's two positives, that means this is going to be positive. It's going to be just a plus b, a plus b. All right? Oh, do I need to rewrite this? All right, you sure? Okay. If you guys got any further questions, just talk to me. So that's just case 3. All right. Case number 4. You got squirrels and stuff. And guys, please be nice to me. Don't make fun of my accent. I know I'm country as all get out. And I was just struggling with the enunciation of saying square. But we're going to get through this. All right, so this is case 4 when you're dealing with squares and stuff. So let's look at this case. Uh-oh. Well, we know we can't, use greatest common factor. We know that we do have squares, but there's something different about this versus this previous example. It has an A. I have X, and then I have an A. I can't factor that. Well, remember how we did the second case of factoring by grouping? The one that is different for the first two problems we did? We're going to rearrange some things. So let's rearrange. So let's rearrange this x squared plus 8x plus 16 minus 25a. Notice I separate that. I move that to the back. I move to the back of the bus like I'm Rosa Parks. It gotta go. It gotta go. So when I did that, now I could factor this and put this in piece by piece. So over here in the first part, we are dealing with squares, remember? And so let me ask you this. Inside that parentheses with that trinomial, do I have a perfect square somewhere? I do. Where is it at? 16. So 16 is a perfect square of 4. So that means my final answer for this should be x plus 4, x plus 4. So let's factor this to check our work. So x times x is x squared. X times 4 is 4x. X times 4 is 4x. 4 times 4 is 16. When I combine my terms, guess what? I get x squared plus 8x plus 16. And that's me checking my work. And that's how I know I'm right. But I'm not finished. All right? So the checking your work thing that we just did, I'm going to erase that because that's not needed at the moment. I mean, that's not needed for the final answer. That's just for me to check my work. So let me clear up. So let's get back to this form right here. All right. Another way of writing this, x plus 4 to the power 2. Because you got the same 4s, that's just that. All right. And we haven't did the 25 yet, but we will. We're going to rewrite it. But remember, if you got ax squared, and again, this still with squares, plus bx plus c, they got perfect squares in it. And because they are positive, you're going to have a plus b, a plus b, or a plus b squared. Just remember that, all right? Okay, so let's finish this up. So I'm done with this piece on the left. This is going to be part of my answer. Notice I did 2 triangles, so that means that I'm almost done, but not done. All right, so this negative 25. 25 is a perfect square of what? So guess what I can do? Why not put this minus, put right there in the middle, and write this as 5a squared. Guess what? You are now finished. You have finished it. This is it. And this is the factoring in various cases. Whew, well workout. But we needed to get through it. All right. The homework you need to have complete. So when we come back to class, we have something to discuss and present. Because one of the things that we're going to start doing in this class is going to the board and putting our solutions on the board. So we could critique and analyze. Because when you take my test, which is now open notes, you're going to be dealing with problems that may be right, may be wrong. You're going to determine that. All right, y'all.